So for a multitude of reasons, we have a new age of space exploration underway. Now, whether it's going to be space tourism, satellites monitoring the Earth, or a telescope to image the universe from a Lagrange point a million miles away, we're in a new age. The next 10 years of space development are going to require visual technologies and venture capital. On our next panel, we have some incredible experts to help us explore how visual technologies and venture capital will evolve in the future of space. I'm going to let the contestants introduce themselves. Kurt, who are you?
Hello, Kurt Eberly here. Can you hear me okay, Peter?
I do.
All right. Well, you said contestants, so that makes me think that there's a prize awaiting us at the end of this panel session. I'm just very curious to know what it is. Anyway, Kurt Eberly here. I work for Northrop Grumman. I started out at Orbital Sciences and then Orbital ATK, and we got bought by Northrop Grumman. And I'm in charge of 3 different rocket programs: Antares, Minotaur, and Pegasus. I've spent my career launching stuff into space, and really excited about this discussion of where vision can fit in, or is it already fitting in. Thanks.
Thank you. Is anyone else, do we have Tej or Stefanie online?
I'm here, Peter. Can you hear me?
There you are. Great. Tej, take it away.
Great. So hi, everyone. I'm contestant number 2. Happy to be here. My name is Tej. I'm the Chief Revenue Officer of Axiom Space. At Axiom, we are building the world's first commercial space station. So what you're going to see in 2 years is our first module will go up and dock on the ISS, the International Space Station, and subsequent modules go up every 6 months to a year. And then when the ISS is decommissioned, deorbited, Axiom Station will be the freestanding successor to the ISS. And I have not been in the business of doing rocket launches my whole life. I've done several product launches, but I'm very excited to announce our first launch, which will be in 2 weeks, which will be the first civilian crew to go up to the ISS. So prior to our modules going up, we have a series of what we call precursor missions of civilians and professionals, astronauts from countries going up. I joined Axiom 8 months ago from Google, was a longtime startup founder and a huge fan of LDV. Thank you.
Great. And Stefanie, are you out there?
Yes, I'm here. Can you hear me okay?
Yes. Thank you.
Okay, well, hi. I'm contestant number 3 and also anxiously awaiting the prize. My name is Stefanie Milam. I'm a scientist at NASA's Goddard Space Flight Center. I'm also a deputy project scientist for the James Webb Space Telescope. I'm actually reporting to you live from the Mission Operations Center in Baltimore, Maryland, working on commissioning this telescope. I've been involved in a number of space missions, including the James Webb Space Telescope, but also future missions and concepts that are going out. Thinking about what's the biggest next best thing that we need for astrophysics and planetary science. How are we going to study new worlds, not only in our own solar system, but across the universe. And I'm very thrilled to be here. So thanks for having me.
Oh, great. Thank you, Stefanie, and nice to meet you. So let's see. By the way, I don't know if anyone caught that, but Tej's company, Axiom Space, they're currently in a pre-product category, but in a couple of weeks, they won't be. That'll be the first privately funded and privately launched space tourism operation to the space station, I think. Is that right, Tej?
Yeah, I wouldn't call it space tourism. I prefer space exploration because the individuals that are going up have been training for months, a year. And our commander is, while he is a civilian now, he's a multi-time astronaut. His name is Michael Lopez Alegria, has been to station a couple of times, but he is going as a Axiom representative. So it will be the first civilian crew ever to go to the ISS.
That is what I should have said. Now, space, I hear, I've never been there myself, but I hear it's pretty empty. But from a VC point of view, it's very hard. How do VCs assess, how should we assess risk for space-based opportunities? Tej, why don't you give us your opinion first, since you actually work at a VC-funded company?
Yeah, so it's interesting. I was a startup founder for 10 years, spanning 3 companies, all were investor-backed. Axiom was actually my first investment ever. It was an angel investment that I made 2 years ago because I really wanted to work in the space industry, and that was my way of making a commitment to myself that this is something I want to do. And I threw out all venture logic out the door because it passed my litmus test of like, oh my God, this is the coolest thing I've ever seen. I have to be part of it. Which I wouldn't be surprised if some of the venture capitalists in the audience have similar mentalities. But now that I'm in there and they hired me as chief revenue officer, I've had 3 board meetings, and we are a venture-backed company. And not only is it hard, but it's very expensive. I think the risk profile is actually understandable by the venture community, but I think where there's a disconnect, or I should say opportunity, is space has historically been a government endeavor, a taxpayer endeavor. And this is the first time, I believe, in human history where you're seeing a public-private partnership like this between governments, agencies, private individuals, investors, institutions. And it's really bringing the best of all of our worlds together. So I think where the cost is high and the risk is high, we need to start thinking of models where the return is very high. So we're not talking billions, we're talking trillions. And we're not just talking trillions, we're talking multiple trillions. And not multiple trillions necessarily per company, but multiple companies creating multiple trillion-dollar businesses, markets, and industries. And we're literally at day 0 of that right now.
Well, that leads to a whole bunch of other questions that I have for you. But before we go there, Stefanie, do you have an opinion on how, I mean, obviously you're working on a space program that's not defense related, but does the US Space Force and the Space Development Agency, which are two, and for the audience, I'm sorry, the Space Development Agency is kind of like I could be completely wrong here, but a DARPA-esque agency specifically about the development of space technologies and space infrastructure. And these are both organizations that are less than 3 years old, right? So does the formation of those change the commercial outlook or commercial opportunities for space, Stefanie?
I don't think so. I think there's probably a new alignment politically on where we're going as far as space exploration and discovery goes. The Space Force approach, coming in as sort of a militaristic approach for, space exploration, but also, as a defense and sort of monitoring of what's going on. Coming from the historic government approach of space exploration and working for NASA, I can say that it's definitely been interesting working with these groups as we've been moving forward. I'm involved with a mission that's called DART. It's an asteroid redirect mission. So this is actually a planetary defense mission where we're going to an asteroid and we're basically bumping into it to see if we can change the orbital parameters of this object. And that's interesting, and it has implications for things like, planetary defense as we go forward, and how that mission has worked with things like the planetary defense and other areas of government in that realm, with a scientist and science mission sort of goals and objectives. It has been really interesting to see how the dynamic is working. And so I think as we're moving forward into working with these other parts of the agencies, the government, or even with future venture capitalism, I think this is only going to help expand and enhance the capabilities that we can do not only for science, but as explorers in general. It's opening doors. It's pushing technology a lot faster, and we can generally move things through hoops faster than we can through a government regulated exploration system. So I'm very interested to see how this is going to develop in the next few years, because as you said, these are still very, very young. And I'm hoping that this is only going to encourage and enhance our capabilities for exploration and science, of course.
Well, thank you. And so, Kurt, you've been launching rockets for both commercial and military operations for decades. Is there any big change coming in this world because of these new agencies or not?
Yeah, I think, Peter, you were very clairvoyant in getting this panel together, because it has, you've got Tej on the cusp of a real paradigm change. You've got Stefanie, which is representing this awesome technology that's just, it's just not commercially viable, right? For James Webb Space Telescope to be built at $10 billion and put out to Lagrange point. Is Lagrange point 1 or 2, whichever one? 2, thank you. Lagrange point 2. It's just, I don't think there's a commercial market there. Maybe there is, maybe I'm wrong, but so you've got this different ends of the spectrum of the government buying space services. And so I do see a lot of change. I see NASA has started buying services instead of buying things. So they used to buy just a rocket, and then a separate group would buy the spacecraft, and then another group would marry them together, and it would all work out in about 5 years' time. And I think the DART mission is I think a heritage example of that. I think it's being built by APL, Johns Hopkins, and then the launch is being procured out of Kennedy and so on. So that's kind of a typical approach. Whereas, behind me, you see one of our Antares rockets that's carrying cargo to the space station. So here we build the spacecraft, we build the rocket, we take care of all the licensing, we get an FAA license, we go to the range and buy range services. And so we're like Space FedEx. NASA comes to us and gives us the cargo on the ground, and then we deliver it to the astronauts on orbit. They never own anything or buy anything that we produce. They just buy a service. And so if you think about buying a service, instead of buying a rocket and a satellite and then having to go and issue a subcontract to this provider and another subcontract to that provider, and the launch date is changing, I got to give you another change order, and so the costs grow. It's interesting to see that I think NASA is kind of leading the way here with the services paradigm, and I don't think the DoD has caught up. Although I think SDA is starting to look that way. Instead of these huge monolithic defense assets, they're promoting the view of a disaggregated LEO constellation that's going to do all these different functions that used to be done by these singular, very expensive assets. So very exciting time, I think. And the fact that NASA is opening up their doors opening up the hatch on the ISS for Tej and his crew to come on board, that's great. It's just going to create the need for more cargo services. So NASA is trying to bring this commercial paradigm to bear. I think it is changing, but I see it more on the NASA side. I think the defense community is starting to realize, hey, we can get more bang for our buck if we use some of these commercial services.
And for everyone's benefit, LEO is low Earth orbit. There's low Earth orbit, there's high Earth orbit, there's GEO orbit. So if these guys drop these terms, GEO is the highest position, stationary position over the Earth. LEO is the opposite, like a Starlink satellite cluster. Okay, so let's talk about the killer app for space, and maybe includes vision and maybe it doesn't. But the killer app for space, like space, first of all, think about the killer app for space now and the killer app for the future, and does launch price impact that relationship? Because launch prices are dropping. They were, say, $50,000 a kilogram in the space shuttle days on a space shuttle, not the most cost-effective launch vehicle, of course. They're $3,000 now for a SpaceX Falcon 9. I think they're closer to $1,000 for a SpaceX Falcon Heavy. Elon says when he launches the BFR, space launch costs will be so low, they're insignificant. Satellites and operation costs are obviously not insignificant. What's the killer app for space, either now or in the future? Or maybe it's the same thing. Tej, I'll pick on you first.
Yeah, so I'll start with an answer I've been saying a lot in the last 8 months is I don't know. And it's not I don't know because it's a non-answer. I think that's the answer. Someone tells you they know the killer app. Either bet heavy on them or do your diligence. For me, I think, as I was saying, it's day zero. I see, just like you saw with the internet or other big shifts in society, we're at that earliest infrastructure stage. And then you'll see a hardware stage, you'll see a software stage, then you'll see the applications. And if I were, and I was around in the .com boom, and I was looking at where to invest and where to put money, and how I'm taking a parallel to space right now, it is in those platforms. It's in the equivalent of what cloud computing would be to the internet if you could have had that vision 20 years ago. And for me, I think the opportunity for the companies and the investors putting right now is building those platforms that will enable those killer apps, multiple killer apps to come out there. And that platform, and the question isn't about the cost of launch being reduced, because then we're still looking at that cost plus model. We're looking at, hey, if it doesn't cost $200 million and it costs $100 million, does that make it better? Where I would rather remove costs from the concept and say every rocket that's going up, no matter what it costs, is putting $1 billion of enterprise value into our shareholders. And when I think of it that way, I think of the infrastructure we're building, I think of the platform we're building, and just like Amazon makes money on every time you call an Uber, or AWS makes money, or you watch a Netflix movie, or whoever's powering the cloud behind Zoom. That's where I think the biggest opportunity is right now.
Okay, Stefanie, what are you thinking about the killer app for space other than James Webb and DART? I have so many questions on everything you do. I can't distract you right now. Sorry.
So killer app. So thinking forward is the way I'm trying to approach this. Is where are we going? Especially thinking of from a NASA perspective, science perspective. Exploration is definitely getting further and further away. There's still a lot going on, obviously close to home. I'm not an Earth scientist, so I can't tell you too much about that, but it sounds like one of the presenters earlier had a lot more to say about that. So what I'm thinking is what we're looking at going forward is bigger, better, and more cost efficient. We had a lot of lessons learned from James Webb, obviously being a pretty hefty price tag for NASA, and we got the benefit of actually collaborating with other space agencies to kind of hackle down on that price a bit, but we still had quite a bit of a shock at our final sticker value. And so going forward, astrophysics wants another giant space telescope so that we can start looking for Earth-like planets and the potential for discovery of Earth 2.0 in the future, and that's going to take a really big Hubble Space Telescope. So James Webb is one thing. But going to the next generation is going to be another thing. And now we have to start thinking about how we're going to get something that big up in space. So yeah, while launch efficiency is getting much better and more prevalent and cheaper, how do we get something that big? It's capacity now. And so on-orbit assembly is now definitely a consideration going forward in the future. And I think having that capability is going to be basically the way that we get bigger, better, faster, stronger as far as space exploration goes. But then the question becomes, how do we test it? So we have this, test as we fly, kind of a philosophy to make sure things are going to actually work, especially when you're sending them 1 million miles away from Earth. So serviceability is still a challenge. We have really cold optics and instruments that, even approaching for servicing with any type of propulsion system is something that's going to cause contamination. And these are issues that we have to think about going forward. So how do we test these things in a piecemeal manner, or even once we're in orbit assembly process, do we test things sort of in situ, or do we wait until we get to our full environment and hope everything works? So these are kind of big things going forward that I think are going to be challenges that we have to face, especially as we're looking at next generation priorities coming out of the science community. But then there's also, communication, big data. These are things that we're already struggling with. And so how are we going to get our data down? How are we sending commands to our spaceship or spacecraft? What are the kinds of things that are limiting our operations and capabilities? And so this is things that we are already struggling with, and it's only going to get worse as we move forward.
Thanks. So Kurt, is servicing the James Webb with a non-contaminating propulsion unit, or maybe just servicing the party that I think Jeff Bezos is hosting at Lagrange point 1, which is why they had to move it to Lagrange point 2, or low Earth orbit datacom to build a space-based internet? Are there any of those ROI positive venture capitalist focused events happening at Northrop?
Well, they say in aerospace, a great way to make $1 million is to start with $1 billion. So, I think Tej has it right that the infrastructure needs, I think, are what is not very glamorous, but really necessary. And I think Stefanie even hit on it, like communications. NASA has a very nice, expensive communication network in space called TDRS, Telemetry Data Relay Satellite System, or something like that. And what if they could, just use some commercial system? Maybe Starlink is going to provide the next generation of in-space comm to get high bandwidth data down from these incredible images that I'm sure we're going to get from the James Webb, and get it down to the ground and a lot quicker. And then NASA doesn't have to have an office of TDRS and buy the next TDRS and then have an office of ongoing TDRS support. And so I think that kind of building the backbone of the infrastructure for comms, for all the support you need in space, I think that is going to be commercially viable. I think you asked about in-space servicing. There's a really exciting part of Northrop Grumman called Space Logistics that's launched a mission extension vehicle that has gone out to one of these perfectly operating satellites in geo orbit that has all these really expensive transponders and antennae on it, but it's just running out of fuel. And typically these kind of geos are built with 15 years of hypergolic fuel, and when they run out, they just reserve the last little bit and push them up to a graveyard orbit. But instead, we went out and grabbed onto the back of this satellite, an Intelsat satellite, and are doing the station keeping and the attitude control using electric propulsion, which is a more modern way of and non-contaminating, I think. And so I think it could be suitable. The problem is, how to get it out to Lagrange point 2, which takes quite a bit of energy, and I think it took upwards of a month or 2 to get out there, even with a very powerful rocket from the ground. So yes, super cool to think about spacecraft in the future. Remember, Hubble was built with servicing openings and so on, so you could get to the electronics, and that was great, but it was in low Earth orbit, and so the shuttle could get to it and the astronauts. So if you think about way further out and all this kind of higher altitude stuff, hopefully it's going to be built with the hooks in it for in-space servicing and these life extension, make it easy, with handles or connectors, or maybe fueling interfaces where you can fuel in orbit. I know there's a company called, I think it's Orbit Fab, that's starting an in-space refueling capability. So I think the infrastructure side of it, Peter, is what's going to be the killer app out in the future. And then, like Tej says, then you can have all the cool stuff that's layered on top of the infrastructure.
And for everyone's benefit, what Kurt's talking about is, there's an object in space, maybe it's a couple of meters across, maybe even smaller. It's very expensive. It's going to fall out of the sky. And the cost of these satellites is, $100 million, $50 to $200 million, depending on the scope of the satellite. And they take another satellite and they basically shove it into the other satellite and it clamps on. Like something, it's really kind of crude, it's nasty. And you just clamp onto the thing, and now you have an extra engine on the satellite that you can maneuver for the next 15 or 20 years. It's kind of freaking unbelievable. What about, and when you do the math, if any of you do the math for this stuff, you'll see this is not easy stuff. It's really hard to position these things. It's really hard to understand how to connect 2 satellites together tens of thousands of miles away from any observable system that we have.
Hey, Peter, could I jump in on something Stefanie said? So I think it actually is the essence of what the killer app will be. She used the word capacity. And this is something that the venture capitalists in the audience can understand, is once we're in the game of adding capacity to whatever that platform is, servers on cloud computing, gas stations up there, physical space, for people to take pit stops, or in orbit manufacturing, whatever that might be. Once we get to the cost side of the model being, okay, well, what's it going to cost me to put that server up there? Well, how much more capacity is that going to give me? That allows us to start changing the customer model to be a fractionalized model. So it's not about, oh, the cost is coming down, so now we add a margin to it, but it's the point where you fractionalize the cost of that server or that CPU cycle down to nothing, right? Look at cloud computing. Right now, if you're a startup, I say this every year, it's the greatest time ever to be a startup. I know there was someone talking about tensor models before. Right now, you go to Amazon or Google Cloud and you're a startup, you're going to get hundreds of thousands of dollars of credit to build your startup. So we're not talking that it's costing you a penny or whatever for CPU cycle or for data storage. They're paying you to build it on their platform. And this is also true for GPUs and TPUs. It's amazing. And once space can get to that point, I think you'll get thousands, hundreds of thousands of companies building those killer apps. Till then, it's only if a satellite's going to cost 100 million, 10 million, whatever, that market's pretty small. If a trip to space is going to cost 50 million, 25 million, 10 million, that's still really high. These are very small. They might be high number of markets, but very small number of customers. And I think until we fractionalize, and the only way you do that is by adding capacity to the infrastructure, which starts by building that infrastructure.
Okay. Let's talk briefly about Earth-focused space-based services that exist now. The big one isn't really imaging, though. The big one might be datacom or some kind of communications going down to Earth. There was this time back in the 90s when there was Iridium and Orbcomm, these kind of low Earth orbit based satellite services to do datacom to the Earth for the last mile. They all went bust because the cost structure was completely wacky, and terrestrial, like Earth-based services, got better really fast. But now we're kind of in this mode where Earth-based services aren't getting better faster. There's mostly because of regulatory issues, not because of technology. And the datacom companies themselves can't really invest in technology. The only people who invest in datacom or terrestrial communications are the hyperscalers like Google and Facebook, because they can, but Verizon isn't really, but Starlink is. So is this a potential for a killer app, like some kind of, I don't use Verizon, I just use satellite services? Is that a future that anybody sees? Anybody got an opinion on that?
Well, I think
we're out there.
I think history is littered with failed LEO constellations, right? You just named a couple of them, and there was a couple that didn't even get started. I think Teledesic was even one of them. There's just such a mountain of upfront capital that's required before you even start bringing in any revenue. And I think even Mr. Musk of SpaceX has been quoted saying that that Starlink, the number of thousands of satellites that need to be deployed, is dependent on being able to build these his rocket engines at a fast enough rate to build enough rockets to be able to launch all the satellites, to get them all up there while within their lifetime and all working together and connected, so that the constellation is really working as a network fast enough to pay down the money that's been raised to build it all. And I think that's exactly what happened to Orbcomm. I know firsthand was they just couldn't pay the debt service on the upfront capital fast enough, get it into service fast enough to pay down the debt service. So I think it remains to be seen. It's certainly really hard, really risky to get that much hardware built on the ground and then launched into space and working in space all at once. But if anybody could do it, I think SpaceX can, and they've got a great start at it.
So what about
Kurt? I think it's funny that you said history is littered with failed satellite attempts, and like the end result of that is our future is literally littered with failed satellites in orbit. But one thing I was going to get back to your question, Peter, about whether it's vision or data. I won't say it's two sides of the same coin, but it's two sides of the same problem. So right now there's this tight bottleneck of data coming down. And if someone's doing some really cool Earth observatory stuff up there, whether that's climate change, or I think I actually heard this example at one of the LDV dinners or events in the past, is looking at like containers, shipment containers from space. And right now, I think the options really are just to send that data down. And not that data, literally the images, the pictures, the feed. And that's a lot of data of stuff not moving. And the people doing the analysis don't really care about those pictures. They care about the insights. They care about the movements. So could you just send down the coordinates? Does it have to be the entire file? And those are decisions we have to make based on constraints, data constraints. But now you start expanding that because, again, really what the customers are looking for are not for JPEGs. They're looking for insights. And then you start putting that edge computing and that processing either on the satellites or in a data center up in space. That is actually mirrored with the cloud down here, but is different. There's obviously latencies issues, and these are going to become bigger and bigger as we go out to the moon, to Mars, and outside in space. But that's the kind of thinking. That's the new IP and technology that I think is going to create a lot of value for all of us, but particularly venture capitalists.
That's an incredibly cool idea. So you're basically saying I push my application to this edge sensor because the cost of communication between the edge and the center is very high. And it's much more efficient to do that. And so I can basically tell it into the satellite and start running my application up there.
Yeah, and then if you remember back in the 90s, that's where CDNs popped up, right? I think you mentioned the last mile. Get it into the hub that's your ISP delivering you stuff. Put the file down there. I remember in 2002, I was at ESPN and we were streaming HD on the internet. That was like the biggest thing ever, and it was all driven by constraints because there wasn't a lot of broadband penetration here on Earth in the US at the time.
Right, exactly. And so, Evan made a post about he wants a selfie. I think that's a really narcissistic or crass use of the, let's just flow tape the James Webb around, take a picture of Evan and flip it back and it can do the rest of its work. But more seriously, the government is now buying, I think, the largest fraction of space-based imagery. There are a lot of space-based imagery companies that exist now. They're getting better and better. I think they're legally or defense related. Like they can't do better than, I think, 30 centimeters. What's the limit, Kurt or Stefanie? You probably know. Anyone have a clue? There's some limit. You can definitely
somewhere
see
around
birds
there
on the ground in the Ukraine, which is sad. But is that a big is that a near-term big ROI generating business?
I think it is. I think we've seen Maxar and some other companies. We've seen unfortunately seen a lot of images from Ukraine from commercial satellites that is the kind of imagery that would used to only be available to intelligence agencies, right? And so you can get that refresh rate kind of on a daily basis or every 2 days based on the increasing number of remote sensing satellites that are in low Earth orbit that you can buy imagery from. And so there's a great example of a services model where I'm just going to buy the thing I want. I'm going to buy a picture from you instead of I'm going to buy a satellite, I'm going to buy a launch, and I'm going to have a ground station, and I'm going to have a squadron that manages the ground station. So I think the government is realizing, hey, we can get, maybe, some percentage of our daily intelligence needs just from buying it from these companies that eliminates a lot of expense for the government. And I think that creates kind of an anchor model for these commercial ventures. Absolutely.
We're kind of doing that in some sense already. Well, we've already started kind of doing that. We have a lot of Earth downward looking satellites, mostly for weather. Think about operations with NOAA, for example. And NASA actually launches, maintains, and operates these vehicles for NOAA. So we are providing that service to, the weather agency. And that is something that we already are doing on a much smaller scale than I think what you're talking about. And I think that as we're getting into this sort of data process of, imaging and, looking at, pimples on kids' backs, that's a whole different level. And I do think the idea of having the service sort of mechanism is the way that will probably go forward and probably be the most efficient and not litter low Earth orbit.
Very cool. Yeah, and Tej, are you guys bringing any cameras up there on the next mission in a couple of weeks?
Yeah, there's already several cameras up on the ISS. When we're going up in a couple of weeks, we're visiting the ISS. But when you think of Axiom Station, our first module going up, I tend to use the cloud computing analogy, but I've also heard people refer to it as like the iPhone and iOS model. So imagine the module is the iPhone. And it's got cameras, it's got sensors, it's got all this stuff on it, it's got storage. And we could create a model where developers can go build apps on that and do it down, and do not whatever they want, but within reason, within those sensors in a safe and secure way. It was interesting that Kurt earlier said that you're pulling this panel together was clairvoyant. Maybe he said it. Literally, what we're doing right now, this opportunity that I know the time has come, would not be possible with the four of us. I'll use us personally as individuals, but our personas, what each of us represents on this screen right now. And there's a few other personas. Literally, the future that we all want is not possible unless we're all working together. And this is not us holding hands and coming together to some nice moment where we weren't working together. But you had asked about, the government and the ROI. Right now, the government, our government, and other governments are a huge customer base. And they're probably the only real market that I can point to where there's demand and supply, and you can look at real economics. Space explorers, private individuals, that's brand new. Commercial opportunities with enterprises, Fortune 100s, that's brand new. That's all being invented. But the government models, before when I said it's been a taxpayer endeavor, that's not a bad thing. That's actually a phenomenal way for us to start building this new business. And before I mentioned public-private partnership, it's not the government's going to now start using services and there'll be a customer and it stops and it becomes commercial. This is a long spectrum of us working all together for a while.
Yeah, private funds built the internet in the first place. Hey, everybody, thank you so much. This has been fascinating. I could go on for hours, but our time is up. Thank you so much for joining us.
Thank you all so much.